Okay, so we're talking about trig identities, proving and verifying. Okay, so trig identities is one of the most difficult things at first to comprehend. Okay, and for my students to actually get a hang of. It's one of those first things that we start doing that they actually have to think on their own, and more importantly, there is no set way of doing it. There is no, do we always use this equation or do we always do it this way? So it tends to, especially those kids that are strong in algebra, cause some problems. So, trig identities. A trig identity is basically an equation, okay? And that equation is true for all values of the variable for which both sides of the equation are defined. So what we're talking about is something that is always true. And trig identities are basically small proofs, and like any proof, the left side needs to equal the right side. So these basic identities we've proved over and over and over again, that sine is y over r, cosine is x over r, and tangent is y over x. So what we're going to do is we're going to use that to prove that tangent is sine over cosine. So we're starting with the fact that, well, tangent is y over x. We know that for a fact. And sine divided by cosine, we replace it with these other identities. So sine is y over r, divided by cosine, which is x over r. Dividing by something is the same thing as multiplying by its reciprocal. R divides out with r, which leaves us with y over x, and left side equals right side. So these are kind of like the formal proofs that you did in geometry, except that we don't have to say it line by line. Okay? Now, trigonometric identity is a statement of equality that's true for all values. So we're going to start with the reciprocal functions. These we already know. Sine is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. That also means that these are true because the reciprocal of both sides, if you take the reciprocal of sine, you get cosecant and 1 over sine. Okay? There are also the quotient identities, and one of them we just proved that tangent is equal to sine over cosine, and cotangent is cosine over sine. Okay, these are all super important identities. We're going to use these a lot. Now, we also have the Pythagorean identities. Sine squared plus cosine squared equals 1, and their variants. Okay, now we'll talk about this in a minute about the changing them using algebra, but I give you guys a formula chart. The formula chart has this first one. I strongly suggest that you make sure that you also algebraically change them like this. So sine, move the cosine on the other side, so sine squared is 1 minus cosine squared. And cosine squared theta is 1 minus sine squared. And the reason is because the less algebra you can do while you're doing a problem, the better. So if I have these identities manipulated a little bit already, it makes things easier. For instance, like this one, tangent squared theta equals secant squared theta minus 1. Okay? And that moving that over to make it negative. And it's much easier that if I see secant squared minus 1, I automatically know that it's tangent. So having these written down will help a lot. And then we also have the even and odd identities, which we don't use as much with the verifying that we do, but they are important as well. Okay? Now, we need to be able to manipulate these basic identities. So, for instance, we know that tangent is sine over cosine. Now we can use this, we can solve it and find that sine equals cosine times tangent. So if we multiply both sides by cosine, we get sine by itself. And we could also manipulate it to get cosine by itself and find that cosine is sine over tangent. Okay? So I'm just using a little algebra to actually rearrange my identity to find new identities. Okay? So now if I see cosine times tangent, I know that that's just sine x. And now look at this one, cosine is sine divided by tangent. Using that idea, the reciprocal identity, that means dividing by something is the same thing as multiplying by its reciprocal, and the reciprocal of tangent is cotangent, so we can change this from sine divided by tangent to sine times cotangent. And we've created a new identity. Okay? So if I see sine times cotangent, that's cosine. And we could take it further and say, look, sine times cotangent, and say multiplying by something is the same thing as dividing by its reciprocal and changing sine to cosecant. And we've created another identity. Okay? So all of these are true statements as long as we've manipulated them correctly. Okay? But all of these all equal to cosine. Okay? So if all of these are cosine, which one should we use? And when do we use it? Well, that's going to depend on what we're trying to prove or verify. So there are going to be some instances where we're going to use this for cosine, or we might see this as cosine, or we might change cosine into cotangent over cosecant. It works both ways. Okay? Sometimes you do have to make something look a little more complicated to simplify it. And I know that sounds strange, but you'll see what I mean when we start getting into these identities and verifying them. Okay? All right. So, verifying these identities. So verifying, we must show that one identity can be simplified so it's identical to the other side. Okay? Never treat an identity like an equation. We're not moving anything from one side to the other side. Okay? We're going to pick one side and we're going to stick with it to make it equal to the other side. Okay? And that gives you our rules. Okay? I would definitely print this slide and have it available. I told you guys this yesterday. Print this slide out, have one in your notebook, and then have another one so that you can have it on your desk so you don't have to have your entire notebook. But these are the steps that we're going to be using to help us figure out how to prove or verify. Okay, if you follow these steps, okay, then you should be good. Now, that doesn't mean automatically you do every single step. You're going to do certain steps if you see them. Okay. Now notice in number 3, it specifically says, as a last resort. As a last resort, transform each term to sine or cosine. Okay. And a lot of my students go for that step first. Okay. That's not what we're doing here. And we're only changing one thing at a time. And the last thing is make sure, number 5, have fun with this. It's like the meme, why aren't we having fun? I specifically demanded it with the Brooklyn Nine-Nine. Okay, think of it more as a puzzle. If you sit here and every time you see a trig identity, you dread doing it, okay, it's going to make your life miserable. Okay, it's not any different than if you're working somewhere that you don't like and every day you walk in there, it's making you miserable, it's going to affect everything else. Okay, so if you're sitting here and every time you see one of these identities, you automatically just bah humbug it, it's going to make this part of the class really long. Okay, so let's put these into practice. So we're going to do some practice problems. Okay, so prove the following. Secant x plus 1 times 1 plus cosine equals 1 plus secant x. Okay, now if we're proving this or verifying this, again, if we're following our steps, we're going to start with the more difficult side first, okay, which means we're dealing with the left side first, right? And we're going to change it to get it to 1 plus secant x. I've given you the answer. This is the answer. That is what we're trying to get the left side equal to, okay? So it kind of gives us an idea where to go. So, for instance, I could change secant, right, to 1 over cosine. But why would I do that? Because specifically on the other side, I have 1 plus secant. So do you see what I'm talking about? The answer is going to lead you on your way. Why would I change secant when I'm trying to get to secant? So let's start by following our rules. And rule number 2 is try to do any kind of algebraic, any distributing, factoring, that kind of stuff. So what I'm going to do first is I'm going to distribute in secant, okay? And when I distribute in secant, I'm going to get secant plus secant times cosine. Well, secant times cosine, when you multiply anything by its reciprocal, you get 1. So that means that this is secant plus 1, and in addition, order doesn't matter, so we've just finished. Secant plus 1 is the same thing as 1 plus secant. Left side equals right side. And we're done. Okay? Let's try another one. Secant equals tangent times cosecant. Okay? Well, in this case, my more difficult side is my right side. Okay? So that's what I'm going to start with. I'm trying to get to secant. So this is my answer I'm trying to get to. Okay? So I'm going to start by changing tangent and cosecant. So tangent, sine over cosine. Cosecant is 1 over sine, which means that sine divides out with sine, which leaves me with 1 over cosine, and 1 over cosine is secant, which means left side equals right side. See? These aren't hard, and you're going to attempt them more than one time, most times. Okay? If you can't get it the first time, you're just going to have to start over again. All right? So let's do something a little more difficult here. Okay? So obviously, we're going to start with the left side because that's the more complex side. So this is my answer. I'm trying to get to secant again. Okay? So where do I start? Well, I got tangent times sine, so we could start there and changing that to sine over cosine, which means I've got sine over cosine times sine, which ends up being sine squared. And then the cosine side, I'm actually going to multiply it and get common denominators. So I'm going to multiply this by cosine over cosine, which gives me this cosine squared. And then since I have common denominators, I can add the two of them, and I get sine squared plus cosine squared. And that is one of our identities. That is the Pythagorean identity. And the Pythagorean identity says sine squared plus cosine squared equals 1. So that means I have 1 over cosine. And 1 over cosine is secant, which means left side equals right side. Okay? These are just basic identities that we're using in substitution. It's just substituting one thing for another. And in this case right here, I use the identity, the Pythagorean identity, sine squared x plus cosine squared x equals 1. So this equals 1. I just substituted. That's all we're doing here. Just like here, tangent equals this. Cosecant equals that. I just substitute in what I think I need and see what happens. Okay? All right. Before we verify this, I'm going to give you the code. The code for the note check is MRKR0KS, all lowercase. MRKR0KS, and that's your note check. All right, so the last one, we've got tangent. Oh, we've done that one. So let's try this one. Tangent squared times cosine squared equals 1 minus cosine squared. Okay. So which side is the more complex side? I would say the left side is the more complex side. So basically, we're going to try to get to here. This is my answer. So I'm going to start by looking at what I've got here. So I'm going to change one thing at a time. Now, if I wanted to, I could change cosine squared. Cosine squared x is 1 minus sine squared x. I could use that and change it to that, sine squared x. But here's the thing. My answer has cosine in it, so why would I want to change cosine? So I'm going to change tangent. So I know that tangent squared x is sine squared x over cosine squared x, which sounds better to me because I'm going to get rid of tangent into sine and cosine. So sine squared x over cosine squared x times cosine squared x. And look, cosine squared divides out with cosine squared, which leaves me with sine squared x. Well, I also know that sine squared x is equal to 1 minus cosine squared x. And look, left side equals right side. Now, I could have very easily, and I'm going to show it to you, I could have done this that way. I could have changed this to tangent squared x times 1 minus sine squared x, like that. And then I would have gotten tangent squared x minus tangent squared x times sine squared x, like that. And then this we've already done. Didn't we do something like this just a second ago? Where it was tangent times sine, which gave us that sine squared over cosine, what we did in the last one. So we could have done something like that and got common denominators here. But it would have taken me, I would have ended up getting the same place. I would have ended up like this. It would have been sine, change this to sine squared over cosine squared minus sine to the fourth over cosine x. And then you would have gotten sine squared x minus sine to the fourth x over cosine squared x. And you would have gone around and around and around, but eventually what you would have gotten to would be in this. You would have ended up with sine squared x times 1 minus sine squared x over cosine squared x. And 1 minus sine squared x is cosine. This would divide out with that. You're left with sine squared, which is 1 minus cosine squared x. And you would have ended up in the same place. It would have taken you a lot longer to get there. Because look, this is right there. Is it wrong? No. Is it longer and more difficult? Yes. Do you get to the same place? Of course. And this is what trig identities are about. Can you get to the same place?